All right, and so we are going to move forward in Unit 3. You just did a whole bunch of algebra review in Lesson 1, and now you're going to see why we did some of that with some of the concepts that we're going to explore in the next few lessons. So we're going to start with Unit 3, Lesson 2, all right, determining if lines are parallel. And you can see that is standard 6.1. I can determine if two lines are parallel. So you've already done the exploration, all right, so we did that in class last time, so hopefully you have some thoughts on that. Now let's talk about what parallel lines are, right? So the first thing is parallel lines are two lines that do not intersect. All right. And what we're going to look at in this unit is we're going to look at two different situations. We're going to look at it in the coordinate plane, which is what we're going to do in today's lesson. All right. And then we're going to eventually look at it geometrically. What if we don't have a coordinate plane? How do we determine if two lines are parallel if we don't, all right, have some of the information that we're going to talk about today? All right. And so parallel lines are two lines that do not intersect and have the same slope, right, and different y-intercepts. And the reason we do that is we have to make sure we're not talking about the same line. All right, if you remember from Algebra 1, when we did like substitution, elimination, we did some graphing, we had a possibility of infinitely many solutions, which is when we were talking about the same line twice. All right, and so that's why we double checked just to make sure we have different y-intercepts. So we want to make sure we're talking about two different lines. All right, so when we talk about determining if two lines are parallel analytically, so that's in the coordinate grid, all right, we're going to verify that they have the same slope. All right, if they do, then we're going to go to step 2. If they don't have the same slope, we can say, no, they're not parallel. We're done. All right, we don't even have to worry about step 2, which is, okay, we have to show that they have two different y-intercepts. All right, so let's flip over here. All right, and let's just look at number 1 here. All right. Okay, so notice what we want to do is recognize or be able to find the slope of each line and then compare those slopes and move forward. So when we look at equation 1, we're in slope-intercept form here. Hopefully you can look at that and see that, oh, the slope of line 1 is 3 over 1. When I look at this line, the slope is negative 3 over 1. And so notice right now, those are not exactly the same. So when we say the slopes are the same, we mean exactly the same. All right, exactly the same. All right, so now we don't even have to worry about verifying part 2 because they don't even have the same slope. All right, so we know they're not parallel. All right, let's move to problem 2. Now, these are special situations, and you have to have a little bit of recognition, all right, for these. So remember, x equals 4 is a vertical line, all right? And so we know it's going to be vertical. Y equals is horizontal, all right? Now, 1, if you remember that, you should know that they can't be parallel, because if they're horizontal and vertical, they're going to intersect eventually, all right? But that also means that every vertical line has an undefined slope, all right? And then every horizontal line has a slope of 0, all right? So we can kind of sketch that. It's like, oh, if I have a horizontal and vertical line, they're eventually going to intersect. So we definitely know that they're not parallel, all right? So having kind of both ideas there to help guide you will make that a lot easier when dealing with, all right, horizontal and vertical lines. Now, let's look at number 3 here. So notice the first problem, all right, pretty easy. I can look right at that slope-intercept form. I know my slope's negative 2 over 1. But when I look at the second one, I can't see the slope. So what I want to do is manipulate this equation to look like this form so I can tell what the slope would be. So to do that, I would subtract 8x from both sides. All right, so 4y equals negative 8x plus 16. And then I would divide both sides by 4, all right, to get it into slope-intercept form. So y would equal to negative 2x plus 4. So if it's not in a form, all right, where we can determine what the slope is, we want to manipulate it so that we can see that. And notice now I can look at this equation and I know exactly what the slope is. It's negative 2 to 1, all right? And so the slopes are the same. So now what I want to do is, okay, do they have different y-intercepts? Am I talking about two different lines? Well, the y-intercept here is 0, negative 9. The y-intercept here is 0, 4. Same slope, different y-intercepts. Therefore, these lines are, in fact, parallel. All right, let's do one more of these together. So let's look at number 4. All right, when I look at number 4, once again, I can look at this line, slope-intercept form. It has a slope of 1/2. I can look at this line, point slope form. I can see that it has a slope of 1/2. So what I need to know now is, do they have different y-intercepts? Well, the y-intercept here is 0, 6. So I need, once again, do a little bit of manipulation here to see what the y-intercept would be. And the way I do that is I'm going to distribute that 1/2 to everything in my parentheses first. So 1/2 x minus 3/2, and then plus 4. And now if I combine like terms, I'm going to get this equation into slope-intercept form as well. So this is 8/2 minus 3/2, so that would be plus 5/2. And so once again, I can see that y-intercept is 6, y-intercept of 5/2. Those are different, equal slopes, so these lines are in fact parallel. All right, so that's the first way. So that's working with equations, all right, analytically. Now, let's talk about if it's numerically, all right? So we want to determine if these two lines are parallel. So notice what I have here is that line 1 goes through these 2 points, line 2 goes through these 2 points. So this is why we did all the algebra review before we got to this particular, all right, lesson, because the first thing I want to do is find the slopes and compare those. And I just always make a quick XY table whenever I'm doing slopes. So 2 to 4 and -3, 8, and I can see my slopes pretty quick. So I go up 4 here and I go down 5 there. So my slope here is -4/5. All right. And you can put the negative in the numerator, denominator, or out front. If it has one negative, the whole thing is negative. So I just put it out front. So what I want to do now is look at the slope of line 2. Make my little quick XY table, -1, -3, 9, 5. All right, and so when I go from -3 to 5, I go up 8. When I go from -1 to 9, I go up 10. And so my slope here is 8/10. And once again, we always want to compare slopes in lowest terms. So sometimes you might need to reduce that slope. So in this case, 8/10 reduces to 4/5. And so once again, we can see that the slopes are not exactly the same. And if they're not exactly the same, the lines can't be, all right, parallel. So I don't even have to go on to try to figure out what the equations are because the slopes aren't equal. All right, now moving on to problem 8. Same idea. We have 2 points, 2 points. Okay, so when I look at line 1, x, y, I got 5, -7, and I have 5, 10. And notice what happens here. My change in y, I go up 17, but I don't have a change in x. So my slope would be 17/0. And this is a recognition thing. If we have 0 in the denominator, it means there's no change horizontally. All right, if there's no change horizontally, that means our line has to be going up and down. So that means we have a vertical line. Now notice something else. Notice what is the same in both points, the x-coordinate. And that's going to tell us what the equation is. So that means this equation is x equals 5. Now notice what happens in line 2. X, y, we have a 4 and an 8 for the first coordinate, and then we have 4, 3 for our second. And once again, notice I get a change in y, which is down 5, but no change in x. And so once again, we have to interpret that, right? No change in x means there's no horizontal movement. So that means I'm only going up and down. So that means I have another vertical line. And once again, when I look here, I can see that my x coordinates are the same. So think about that. I go from 4, 8 to 4, 3, right? So I'm going just up and down. So you can think, oh, that's my vertical line. So it's x equals 4. And once again, conceptually, right? Vertical line, you should hopefully know that those are going to be parallel. So there you go. All right, let's do one more here. Let's look at number 9. Let's look at number 9 here. All right, and so once again, right, going to find those slopes right away to see if we have to do more work. All right, so the first thing is that we have to have equal slopes. So -5, -8 is my first point, and then 4, -5 is my second point. All right, my change in y, I go up 3, x is up 9. So my slope is 3/9. And once again, we always want to reduce that to compare in lowest terms, and that would be 1/3. All right. Now I want to look at my line 2 here and see what that slope is. So I have 1, -11, and then 2, -8. All right. When I go from -11 to -8, all right, I go up 3. When I go from 1 to 2, all right, I go up 1. And then once again, the slope here is, all right, 3 to 1. All right, So when I look at my work here, right, the slopes are not equal, all right, so I don't have to worry about, all right, my lines being parallel. Now, if they were equal, then we would try to write the equation. And once again, this ties in. I'm just going to show you this real quick, right? So I would say y equals 3, and then I can take either point, x minus 1 minus 11. So this is getting back into the algebra that you did, all right, before this lesson. So if you need to write the equation, you take your slope that you found, you take one of your points, all right, and then you go through, all right, your process. And so I can distribute, right? So 3x, negative 3, bring down the negative 11. I can combine like terms, right? So if you need to, you're going to write the equation just like you did in the algebra review that we completed beforehand. Okay, so hopefully, all right, you kind of feel better about finding or determining if lines are parallel numerically. All right, so one more now, and this is probably the easiest, which is graphical, right? Because with a graph, we can see right away whether or not they have the same y-intercept. All right, so that's really easy. We don't have to worry about writing an equation. We know whether they intersect. We're done. So all we have to do is find the slopes, all right? And we do want you to find the slopes. Don't be like estimating and be like, I think they're parallel. No, they're parallel, all right? So write the slopes. Now, it's a little hard to see, but it is this horizontal line in number 10 here, and this horizontal line right here, if it's a little bit hard to see in your packet. And what we see is that those are two horizontal lines. Those both of those lines have a slope of 0, and we can see that they are in fact parallel. All right, and then that's it. That's all you have to do with graphical. What's the slope of the first line? What's the slope of the second line? All right, if they're the same, we know they are parallel because we can see if they intersect or not in the graph. Now, once you know 11, you might casually look at it like, oh, they don't intersect, right? But be sure. So find your slope. So notice slope is rise over 1. So I go down 1 and over 3. So the slope of my first line is negative 1/3. If I find the slope of my second line, I go down 1 and I go over 4. So the slope of that line is negative 1/4. They're very, very close. And in the picture, they don't intersect, but eventually they will. So that's the other piece, is that when we say they don't intersect, we mean anywhere at any point in time, not just in the little frame of reference, all right, that we are looking at. So we're only looking through a small window, right? So these two lines exist forever to the down on the right. They exist forever, okay, back and to the left. So when we say that they're parallel and we say they do not intersect, we mean anywhere at any point in time, all right? So it might look like it in the picture, but no, from the slopes, they're not equal, lines aren't parallel. All right, two more here. All right, two more here. So let's look at number 12, right? And once again, we can see, yep, they don't intersect in the picture, right? Different y-intercepts, 2 here, negative 10 there. So we just find those slopes. So the slope here, 1, 2, 3, 4, 5. So I go up 5 and to the right 1. So my slope of the first line is 5 over 1. My slope of my second line, I go up 5 and to the right 1. So these two lines do in fact have equal slopes. All right, equal slopes, different y-intercepts, they are for sure parallel. Now you should love 13, right? 13 requires no work whatsoever because when we look at these two lines, they intersect. And the first thing we said, right, on our notes right here, right, is that they do not intersect. So if you have a graph and you see that the point or the lines intersect, right away we can jump, yep, they're definitely not parallel. All right, my friends, so that wraps up our work on determining if two lines are parallel in, all right, the coordinate plane and with algebra versus geometry. All right, so have those notes ready and we will see you next time.